What is a quantum computer? The word quantum, according to the free online dictionary, means the smallest amount of a physical quantity that can exist independently. Quantum computers use nature's smallest parts to do calculations. Moore's law states that the number of transistors per square inch on integrated circuits doubles every 18 months. Loosely, the computation power of a computer doubles every year and a half. As the years go by, transistors get smaller and smaller. In order to continue this trend, computers will eventually enter the quantum scale, using atoms as transistors.
How is a quantum computer different than a normal computer? Take a look at your laptop. That is not a quantum computer. It uses a huge group of semiconductors to perform calculations, while quantum computers use much smaller parts on the scale of single atoms. This is not the only difference, or the most important one. William will explain the first difference.
Normal computers work by having transistors be in either on or off state. You can imagine this like a light switch that either turns the light on or off depending on how you flick it. Quantum computers work differently. They work more like a knob that dims lights. There's an on switch, there's an on state and an off state, but there are a bunch of in-between states where the light's dimmer or not. A normal computer with 3 switches can be in 8 different states, or 2 to the 3rd power. But if a quantum computer has 3 qubits, it can be in more than 8 states. If you're interested in why this is true, you should do some research into how quantum entanglement relates to quantum computing.
Alright, I guess that's a wrap.
A surprising side effect of these in-between states is that they allow quantum computers to run multiple calculations at once, where a classical computer can only run one calculation at a time. You may think your computer can run 2 calculations at once. After all, I can browse Facebook and Reddit at the same time. But a program isn't the same as a calculation. Think about your calculator. The older the better, but bust out those TI-84s. When you type in a big set of numbers, it takes a long time for it to spit out the answer. If your calculator was a quantum calculator, you could run a second equation while you were waiting for the calculator to load the first equation, and your calculator will work on finding an answer to both problems simultaneously. A result of these 2 facts is that very small quantum computers can do intricate problems very efficiently and with fewer resources. A quantum computer with 30 qubits is about as powerful as a normal computer with a processing power of 10 teraflops. One teraflop is just 1 trillion flops. For reference, an average laptop can have anywhere between 7.5 to 0.76 gigaflops. 1 gigaflop is 1 billion flop.
How can quantum computers break codes? Quantum computers are very good at breaking cryptographic systems. Cryptographic is an admittedly intimidating sounding word. Cryptography means the art of writing or solving codes, according to the online Oxford Dictionary. Why are they so good? The most popular way to encode things is the RSA algorithm, which uses prime numbers to encode things. This works well because very large prime numbers are hard to find, almost impossible. Quantum computers can break these codes because their special properties allow them to factor numbers much faster than normal computers, so they can find large primes quickly. If you are interested in why this is true, look up information about Shor's algorithm.
How could this affect society? We rely on RSA encoding in our everyday lives. Things that use RSA include websites that use HTTPS, email systems, room cards at hotels, and DRMs, or digital rights management. HTTPS is a secured web page, a system that allows you to purchase things online and not have your identity stolen. This security could be compromised, which would have widespread effects on things like online purchasing and banking. Quantum computers can quickly break any code system that relies on prime numbers, not just RSA codes.
Can quantum cryptography fix this? Although quantum computers destroy RSA, they offer a safer alternative, quantum cryptography. Quantum cryptography is unbreakable because qubits react uniquely when they are read. This means that if someone was to attempt to secretly eavesdrop on all of your communications while you set up a code with your friend, you would be able to tell your security was compromised. Quantum computers may break old encoding systems, but they will quickly usher in a new wave of pure perfect security.